Everything needs energy.
Including us shooting this basketball.
Could be a better source of energy than nuclear energy.
Nuclear energy. Welcome to Nuclear Chemistry Cram Session. Today we're going to learn about topic number 8, applications of fusion and fission, and comparing nuclear energy to other types of energy. First, let's have an overview of fission and fusion. Fission is the splitting of an atomic nucleus. Fusion is the joining of two nuclei. Let's pass this on to Daryl.
Huh? Sorry about that. So, nuclear application. We'll start with weaponry. The first type of bomb relies on fission. More commonly, it is known as an atomic bomb or an atom bomb with the abbreviation of A-bomb. In order to create a fission bomb, the weapon must be assembled with a supercritical mass, the amount of material needed to start an exponentially growing nuclear chain reaction. The energy released by fission bombs can equal range from under a ton to nearly 500,000 tons of TNT. Possibly the best known fission bombs were the Mark I and the Mark III. They were better remembered as Little Boy and Fat Man, which had been used on Hiroshima and Nagasaki. These two nuclear weapons were the only ones ever utilized in warfare. Fusion bombs, or thermonuclear bombs, are much more powerful. They utilize fission to ignite fusion, and many times they end in another fission stage. The term H-bomb has been used to denote this kind of bomb due to its usage of hydrogen fusion. Although fusion itself does not produce as much fallout as fission, both fission and fusion bombs end up producing similar amounts of nuclear fallout because all nuclear weapons employ some kind of fission. The RDS-220, called the Tsar bomb, is likely the most famous fusion bomb. It was a massive three-stage bomb, initially designed as a 100 megaton bomb that was later scaled down to 50 megatons for testing. The mushroom cloud from the drop exceeded the stratosphere and extended into the mesosphere. The explosive power of the Tsar bomb gave it the title of most powerful man-made weapon ever detonated. An overall challenge in nuclear weapon design is ensuring that enough fuel is consumed before the weapon destroys itself. In fact, only 1.38% of the uranium was consumed in Little Boy, with the rest being blown away before participating in the chain reaction. Currently, the two designs used to create nuclear weapons are the gun-type assembly and the implosion assembly. Little Boy was the former and Fat Man was the latter. And I now pass it back to Raquel and Alex for nuclear energy.
Hello, my name is Alexander Chung and I will be helping Daryl and Rachel teach you today about nuclear energy. Heat in nuclear power stations is produced through controlled nuclear fission chain reactions. Neutrons smash into the nucleus of the uranium atoms, splitting them in half and therefore releasing energy. Then, carbon dioxide gas, or water, is pumped through the reactor. The water is heated to make steam, which is then used to drive the turbines and generators.
In the nuclear reactors, the chain reaction is kept in check by the use of control rods, which are usually made out of boron and cadmium. More neutrons are absorbed when the rods are lowered into the reactor. In order to generate more power, the rods are raised so that more neutrons can crash into the uranium atoms.
Energy sources can be classified into three categories: fossil fuels, renewable sources, and nuclear sources.
The energy from fossil fuels includes energy obtained from coal, oil, and natural gas. Renewable energy sources include solar, wind, hydroelectric, biomass, and geothermal power. Nuclear powered sources include fission and fusion.
Fossil fuel only requires direct combustion for generating energy, but produces an excessive amount of pollution.
Renewable energy sources have characteristics which limit their ability to play a major role in meeting electricity needs.
Solar energy is logical, but has limited potential since solar panels only gather energy during the day.
The same applies to wind energy, which is generated through windmills. Like solar energy, it is not always available due to environmental circumstances.
Water falling through large dams makes up hydroelectric energy. Many countries have suitable dams, thus limiting further major development of hydroelectric energy.
Biomass energy is a conversion of energy stored in plants into energy that we can use. It is likely to only play a small role overall.
Geothermal energy comes from natural heat below the Earth's surface.
Nuclear power provides high amounts of energy, which help in meeting energy demands while keeping costs low. Compared to other sources, energy from a typical uranium reactor is much greater.
For example, 1 kilogram of uranium in a reactor yields 2,000 times the energy from combusting a 1 kilogram rock of coal.
This is why fusion is seen as the energy of the future.
Needs energy.
Including us shooting this basketball.
Bomb-man, nuclear fission in here, I said bomb-man.
Everything
Make a mushroom
Including
cloud,
us,
I
this
said
basketball.
bomb-man. Everyone on the ground, there is need to feel so frightened, bomb-man. There's a chain reaction, I said bomb-man. You release energy, you can explode. If there's critical mass, there's only one way to detonate. You gotta run from the B-O-M-B. You gotta run from the B-O-M-B. They have explosions from a little boy. There are bigger ones from the fat man. B-O-M-B. You gotta run from the B-O-M-B. You can fall on the ground. You can hang in the sky. You can die within the clouds. Bomb-man, can you control yourself? I said bomb-man. Exceeds critical mass. I said bomb-man. You'll be self-sustaining, and you got to know this one thing. No bomb does it all by itself. I said bomb-man. Has friends that help him out. Fission and fusion. To the B-O-M-B, they'll make you release energy. You gotta run from the B-O-M-B. You gotta run from the B-O-M-B.